Welcome, ladies and gentlemen. So what I'd like to do is show you how to graph the cosecant function as well as the secant function when we have a vertical translation. Now, in addition to a vertical translation, in this example, I have a change in the period. And in this example, I actually have a phase shift. So we actually have a couple different translations. But the main important thing is doing, well, what do we do when we have a vertical translation? Well, just like when we graphed the cosecant and secant graph before, the main important thing is really identifying the information, identifying the period and x scale first, and then also kind of using the reciprocal graph, identifying the amplitude to graph the reciprocal graph so we can see what it's going to look like. All right, so first things first is let's go ahead and determine what the period is going to be. I need a black marker. I got a black marker. OK. So the first thing we're going to do is determine the period. So the period, remember, is just going to be 2 pi divided by b. Well, b, again, is what is being multiplied by your x, which is just pi. So that equals 2. Our x scale is going to be our period divided by 4. So that's going to be 2 divided by 4 equals 1/2. All right. There is no phase shift in this example. You can see that I'm not shifting left to right, so I don't really need to do the start. We are going to start at 0. However, we do have an a. Now, we're not going to graph. Remember, cosecant and secant do not have an amplitude. However, what we are going to use to help us with this is graph the sine of using the same function, but a sine. And this one does have an amplitude, which is the absolute value of 1/2, which is just equal to 1/2. So that's very, very important. That's very, very important when we're looking at this. Is you have the absolute value of 1/2 equals, our absolute value is 1/2, because that's going to tell you for our dotted line, the sine graph, how high we're going to go up and how low we're going to go below to help us with the graph. So the next thing, though, that's important is also we identify that we have a vertical translation. Now, instead of my intercepts being at 0, I'm basically going to take that whole graph and I'm going to shift it down 2 units. So that's very, very important for us to know, because when you think about it, instead of our graph going down to -1, well, now it's going to go down -2 units. But our graph is actually, since the amplitude is only 1/2, it's only going to go up to 1/2 and down to -1/2. But if it's translated, then that's going to at least go down 3 units. Very important to know. So I'll explain here how I'm going to do this here in just a second. So let's go ahead and say, all right, here's my y-axis, here's my x-axis, right? Typically, we would graph going up to 1, going down to 1, right? Well, but now remember, we're translating. Everything that was previously on the x-axis, all these intercepts, are now being translated 2 units down. So 1, 2. OK, so now basically my x-axis is being translated to 1, 2, 2 units down. And just like I did with the other functions, I like to graph a dashed line, because it's important to know where the graphs intersect, right? Where they intercept the x-axis. So it's very important for that case. So therefore, you can see that, all right, they're going to intercept, and to kind of plot those, because that's helpful when taking the sine graph to be able to graph the cosecant graph. All right, so the next thing we're going to do is go ahead and, now remember, the amplitude is, when graphing the sine graph, is the half distance. So it's basically going to tell you from where it intercepts how high it's going to go. So since our amplitude in this case is going to be 1/2, I'm going to go from my intercept, I'm going to go up to 1/2, down to down 1/2. Well, remember, our axis has been shifted down. So really, it's going to go up here to -1 1/2 and -2 1 1/2. OK, so that's where my graph's going to be. And now, basically, let's go ahead and draw in the x scale. So the x scale is going to be at 1/2. So I'm going to do 2 full periods. So I have 1/2, 1, 3/2, 2, 4/2. So this would be 5/2. 6/2 would be 3, 7/2, and then 4. OK? So remember, these are going to be telling us where all the critical points are. But now we're doing everything down from over here. So when graphing the sine graph, again, we're only using the sine graph as an aid to help us graph the cosecant graph. So to graphing this, we know it's going to still start here. But then it's going to go up to its maximum, intercept, minimum, back up to intercept. So there's an example of one period. And then I can just continue that pattern. OK? So what's nice about that, again, the reason why I know, remember when we're doing our critical points, you have intercept, maximum, intercept, minimum, intercept. So it's nice to kind of have this x-axis kind of transform down so we know where those points are going to be. However, as I mentioned, ladies and gentlemen, this is just to give us an idea of what the graph's supposed to look like. We still need to graph our cosecant function. So remember, wherever there was an intercept, just because it's been shifted down, this point would have still been an intercept. So therefore, that's going to create an asymptote. So all the points that would have been intercepts are your asymptotes. And then all the maximum and the minimums are also going to be points on our function. And they are going to be in the opposite direction. And they are going to approach our asymptotes. OK, so there you go, ladies and gentlemen. That is how you graph our cosecant function. All right, the next one, I have y equals secant of x plus pi halves plus 1. So basically what we're going to do in this example is, again, look into graphing the cosine function. Now, what I did again in this video, what I did in the last one is I didn't really put any transformations. You can see here I had a, I had change of period, right? Well, this one, there's no transformations. There's no a, there's no b, there's no c. Well, actually, there is a c. So I am going to now affect my phase shift. But as far as the amplitude and the period, those are just going to, or there's no amplitude, but the shape of the graph is going to remain the same. So, or the x scale. So the reason why I've been talking like that is I know the period is just going to be 2 pi. I don't need to go through all this math. The x scale, well, just like my initial period of the parent graph, the x scale is going to be 2 pi divided by 4, which is pi halves. Now, I do need to do the start. Now, remember, the start is you take whatever's inside your function and you set it equal to 0. The reason why we set it equal to 0 is because initially our initial period starts at 0. So if we're going to be shifting it, if we have a transformations, we're going to need to find a new starting point. Well, in this case, it's going to be x equals negative pi halves. OK, this is like the exact same. All right, so I think this is the exact same. It might be. OK, so now, and then the other thing is we're going to go up to 1. Now remember, the cosine graph went up to 1 and down to negative 1. So that's going to remain the same. But now I'm shifting my graph up 1. So when I go ahead and schedule my graph, which I'm going to do 2 periods to the right here again, typically we had our graph starting at 0 or starting at 1, and then it went down to negative 1. Well, now that's being shifted up 2 units. So what I'm going to do is I am going to transform, or up 1 unit. So I'm going to take my x-axis, and I am going to shift that up 1 unit. So therefore, not only do I need to include 1, but now I need to include 2. So now my cosine graph, because that's the reciprocal of this graph, I'm going to graph the cosine graph, which is the dotted red line. So therefore, I can help make the asymptotes and the curves for my secant graph. So the next thing we need to do is make sure we have our x scale. Now remember, this is at 0, right? Well, we're not starting at 0. We're starting at negative pi halves. So that's very, very important to remember. We're not starting at 0. That was the initial period. We have a phase shift, which is now starting at negative pi halves. So I have negative pi halves, 0, pi halves, pi. So 1, 2, 3, 4, and 3 pi halves. That's going to be our first period. So let's go ahead and draw the first period first. Again, remember it's cosine, right? Here's where the intercept is. So it's going to start at its maximum, which is going to be up here. Then it goes to its intercept, minimum, intercept, maximum. So the graph is going to look something like this. OK? Then we can just continue on that, right? So we're going to have to add more things to our x scale. So we'd have 4 pi halves, which is 2 pi, 5 pi halves, 6 pi halves, which is 3 pi, and then 7 pi halves. OK, so now we can just keep on continuing up. So we go here. Then we go to the next one, next one, next one, Back up. Boom. Now again, guys, the whole purpose of this is so now we see, all right, so now that we've graphed cosine, which is very helpful, now we can just easily and quickly graph the secant. Now remember, wherever there was a intercept, right, all these points, those are now going to be asymptotes. Because if it didn't have a vertical translation, those would all be intercepts of our x-axis. And then now, all we're simply going to do is take our points from our maximum and our minimum, and we're going to draw nice little curves that are going to approach our asymptotes. And then we are all finished with our graphs. So there you go, ladies and gentlemen. That is how you graph the secant and the cosecant function when you have a vertical translation. Thanks.